Today I'm gonna try to do this budget app on FreeCodeCamp, which is the next project. I haven't read this, not even looked at it. This is the first time reading. So complete the category class in budget.py. Should be able to instantiate objects based on different budget categories like food, clothing, and entertainment. When objects are created, they are passed in the name of the category. The class should have an instance variable called ledger that is a list. So I think this is the testing file, the main file. And here there's different kinds of objects, yeah, that are instantiated from the class. And this is the file that I have to write stuff on. The class should have an instance variable called ledger. So I have to look up what is an instance variable. I think they talked about it in the course, but I don't remember. And I just realized after I did the last stream that the audio
All
was
right,
not
guys,
recording,
welcome
but now I think it is.
back. And in this video, I want to talk to you about a class
The audio from the videos.
variable and an instance variable and how they're different because it's not only important just between, understanding the definitions, but also for understanding exactly how your objects are made up. It's going to give you a really good understanding and, help you pretty much become an awesome programmer. So I'm going to make a class, and this is going to be a really simple example just to help demonstrate between a class variable and an instance variable. So this class, which I call girl, is going to have two variables. That's it, one of each. The first one is going to be a class variable, and I'm going to set this equal to gender female. Now, what a class variable is pretty much any time you create an object from this class, it's the variables that they have by default. So, of course, every object that's of type girl is going to have female as their gender. All right, simple enough. So now that we understand that, that was like really easy. Let's go ahead and talk about instance variables. So make another init method and pass in a name. So now what I want to do is I just want to make a new variable called name that belongs to this class and set it equal to whatever name we pass in. So basically, whenever we create a new girl or a new object from this class, it's going to have two properties, a gender, and they're all going to be female, and it's also going to have a name. Now, the name is going to be unique to each object. So for example, every single girl is going to be female, but every single girl is also going to have a different name from one another. So this right here is an instance variable. It's unique to each girl or each object. This is a class variable. It's shared no matter what object you create, no matter what girl. So let's go ahead and just look at some simple examples right now, just to pound it into our brain. So girl are
So the class is more general. Every instance of the class you create is gonna have this property, and when instantiate is only if you determine.
I'll name this one Rachel, and I'll make one more girl, and I am going to name this lady Stanky. I really don't like Stanky because she stinks. So the first thing we can do, of course, is whenever you're using class variables or instance variables, you pretty much treat them the same exact way. It's just how they're built in your class. So you can print out our gender. Also, let me just copy this because I am lazy. So pretty much, if we run this, we can see female, female. Anytime we create a girl, she gets female automatically. Pretty much anything we create from this class is going to have that class variable. So whenever you're coding, it kind of looks the same, no matter if you print out their gender or their name. But since we made the class, we know that there is a big difference between a class variable right here and an instance variable. So again, if you ever hear me use the term class variable, instance variable, just remember this. Anytime you use a class variable, it's pretty much default whenever you create an object from that class. Anytime you use an instance variable, it's unique.
And I think it's always the same way that class instantiated. I have to do this init stuff. Then put self here. Yeah. Dot dot dot. something like this. Type is probably a special class from Python. No, apparently not. At least it's not here. So class should have an instance variable called ledger. I think this is what it means. There is a list. So this should be a list. I think I'm gonna watch the video again. To be honest. The class should also contain the following methods. A deposit method that accepts an amount in description. If no description is given, it should default to an empty string. So it's a dictionary that has amount and description as keys. The method should append an object to the ledger list in the form of. So it's gotta have a method that when it's called, it appends a dictionary to this list. I think I'm gonna write down the things that I'm gonna search for because I'm new to this, so I don't know most of the stuff. I know the concepts and I saw the videos, but I'm not really familiar with building anything yet. So object method. Wanna see how to do that and how to call normal class. I know there is a difference between classes. There's subclasses and classes. I vaguely remember something like that, where we have a parent class and then you can have other classes. I'm not sure if this is going to be necessary for this, but it might be good to revisit how that stuff works. Is a little bit confusing. A withdrawal method that is similar to deposit method, but the amount passed in should be stored in the ledger as a negative number. So it's the same logic, just negative number. There are not enough funds. Nothing should be added. But I'm not sure if this means that if the person puts a number, the code is going to transform the number into a negative, or if it's only supposed to accept negative values. So I have to just see about that. There are not enough funds. Nothing should be added to the ledger. This message should return true if the withdrawal took place and false otherwise. Should be stored in the ledger as a negative number. So it doesn't have to do with the first method. It just stores the value on the same ledger. This method should return true if the withdrawal took place and false otherwise. If there are not enough funds, nothing should be added to the ledger. So that's how it knows. So first, you gotta check the ledger, see if there gotta access the instance, the amount, the sum of the amounts from all the objects. And if it's zero, then, or if it's bigger, smaller than the amounts that wants to withdraw, returns false. And if it's less, it returns true. Get balance method that returns the current balance of the budget category based on the deposits and withdrawal that have occurred. I'm not exactly sure what this means. Turns the current balance of the budget category based on deposits and withdrawals. So I'm not sure if it wants me to return the sum of the amount and withdrawals, or if it wants me to return the whole object. I think it's wants me to return the whole ledger to get balance. And I'm not really sure if there is a way. I'm gonna store each time. I'm not gonna delete anything from the ledger apparently with each withdrawal and deposit. So I guess they're all gonna just stay there regardless of the balance. A transfer method that accepts an amount in another budget categories arguments. I'm also not sure. So here I think is the instance, and here is where I'm gonna do the methods probably. So I think the class only gonna have the instance ledger, and then I do the positive withdraw and transfer in the create span chart. I'm gonna have to look at the video again, probably watch some more videos about class, instance of a class, and that stuff. Transfer method that accepts an amount, none other budget categories arguments. The method should add a withdraw with the amount in the description transfer to destination budget category. Should add a withdraw with the amount in the description. Transfer to destination budget category. The method should then add a deposit to the other budget category with the amount in the description. Transfer from source budget category. The method should then add a deposit to the other budget category. The amount in description transfer from. So this is the description, and then the amount is gonna be whatever the deposit is. If there are not enough funds, nothing should be added to the either ledgers. So first, I should check for the funds, just the sum of the amount. This method should return true if the transfer took place and false otherwise. So first it checks the amount, then creates the transfer of the amount in description and adds or take it off. No, adds the amount to the other adds the amount to the other budget and takes it off from that cent. A check funds method that accepts an amount as an argument. So these methods are functions, if I understand. So maybe it's each one for each thing. I have great spend charts. Check funds method accepts an amount as an argument. It returns false if the amount is greater than the balance of the budget category, and it returns true otherwise. This method should be used by both the withdraw method and transfer method. So this should probably be the first one that I make. Yeah. When the budget object is printed, it should display. So when the whole object is printed, title line of 30 characters where the name of the category is centered in a line of these characters. So like this. A list of the items in the ledger. I'm trying to think about. I'm not sure if I understand what the object is. If it is all the methods combined, and if all of them are just on one place. So I think this is a class, and this is the general class, and this is creating. Uh, yeah, it's still confusing. I'm gonna have to watch some videos to understand. List of items in the ledger. Each line should show the description, the amount, and amount. The first 23 characters of the description should be displayed then the amount. The amount should be right aligned, contain two decimal places, and display a maximum of 7 characters. Yeah, this is gonna take a long time probably for me to do. Align displaying the category total. Besides the category class, create a function outside of the class called create and spend chart. Oh, that takes a list of categories as an argument. It should return a string that is a bar chart. So this is supposed to take list of categories as an argument. Then returns a string that is a bar chart. I need to look this up as well. Not sure if I understand what this means. The chart should allow the percentage spent in each category passed into the function. The percentage spent should be calculated only with withdrawals and not with deposits. On the left side of the chart should be labels 0 to 100. The bar chart should be made out of the O character. The height of each bar should be rounded down to the nearest 10. Okay, food, clothing. I'm assuming these are the different categories. Oh yeah, percentage spent by category. So it goes from 0 to 100%. So it's kind of like a graph. Have food, clothing, auto. Just see what's the percentage. That's actually kind of cool to build something like this. I can see how it can be useful in the future. The height of each bar should be rounded down to the nearest 10. The horizontal line below the bars should go through spaces past the final bar. Each category name should be written vertically below the bar. There should be a title at the top that says percentage spent per category. So I'm assuming I have to do all of this on one string, or each string is going to be a chart, a bar chart. Some of these lines here, I don't know. Yeah, the chart should show a percentage. So the chart is only the percentages, I think. I don't know. Still confusing. The horizontal line below the bar should go to a space specifying bar. Each category name should be written vertically below the bar. There should be a title at the top that says percentage spent per category. This function will be tested with up to 4 categories. Look at the example output below very closely. Make sure the spacing of the output matches the example exactly. The unit tests for this project are in test module. Development, writing the budget, use main for the test, and then when click run is gonna run the main, which probably is gonna call the budget file. We imported the test from test module to main file for convenience. Okay, so now let me search this stuff.
To that specific object or that specific instance of this class. Simple concept, but I just wanted to explain it because I don't know. That's what I'm doing, teaching you guys Python. So thank you guys for watching. Don't forget to subscribe. And in the next
Yeah, I think this is gonna take a long time. Probably not gonna be able to finish this today. And I might not even be able to finish in the overall 8 hours that I have to finish this. Because it seems
In this video, I just
too
want to
hard.
clarify the difference between class and instance variables in Python. If you missed our previous video on classes and instances, I recommend you check out that video first, and I will leave a link in the description below for you to do so. Hey everyone, in this video, I just want to clarify the difference between class and instance variables in Python. If you missed our previous video on classes and instances, I recommend you check out that video first, and I will leave a link in the description below for you to do so. So, quickly, a class in Python is a type of object that allows us to create a template of literally anything we want, whereas an instance is a copy of that class, just with the values filled in by whatever makes that instance different from another instance of that same class. So, we can think of some things that we would tell someone if we were describing a car. Things like the manufacturer, the color, the year, the mileage, the number of doors on the car, things like that. And that is our class. Whereas an instance takes that template generated by the class and actually gives it values. So it could describe a 2015 Honda Civic, for example. So, now after that quick review, what is a class variable? And what is an instance variable? Well, a class variable is a variable that is defined within our class, or within our template, if you will. And this variable will be inherited by our instances as they are created using the class template. So, if we wanted to know what type of vehicle our class is defining, we could say that the class variable of vehicle is equal to car, and all instances of this class will inherit that. Obviously, this example is a bit silly, but I hope it makes it clear to you what a class variable is. Okay, so if a class variable is a variable that is given to all instances of a certain class, well, then what is an instance variable? Well, if you think about the variables under our init method here, and the ones that we considered, well, they're going to be unique to each instance of a car class, right? If we had a lot of cars to sell, all the instances, the unique cars, would all have varying manufacturers, years, mileage, and things of that nature. But they still all fall within the class of car. So, the unique variables we associate with an instance of a class are called instance variables, which should make sense with the name, right? They are variables that change with each instance. Therefore, instance variables. Same as for class variables. They will be unique to one class, but since instances are created from that class, they inherit the class variables when they are created. To access our class and instant variables in, let's say, a print statement, it can be done like so. Let's print a class and instant variable from our previously created Civic 2015 instance. To do this, we just call the instance and then tell Python which variable we wish to call. And for this portion, the class and instance variables act identical. As you can see here, just from this print portion, it isn't readily apparent which is a class and which is an instance variable. We could inherently use logic to figure out which is a class variable and which is an instance variable, but my point is that you can call them in the exact same way. Thank you for checking out this video, and I hope it helped your understanding of what a class and an instance variable is in Python, and how you can begin to implement them into your Python codes.
Thing is, I'm not really sure if I'm what I'm supposed to put here. I think it's just the ledger then. Instance variable called ledger. Methods. I should look for. So I think I have to make the ledger for each class. So when it calls, I can actually try to call here. Let's use one of the examples. I don't remember how the guy called.
Hello, everyone.
The class.
We could inherently use logic to figure out which is
Equals make equals category. Now I'm not sure what I'm supposed to do here. I'm supposed to put ledger there or nothing. Try to run this, see what happens. Food budget dot category. Food takes one position of argument, which we're given. So what does it mean? If I just have self here, so I guess that's how you create it. So here's creating, then it's calling the methods from the class. Let me search this. See. Define the argument window as a positional argument, but then initialized it using a keyword argument. What is a positional argument? I'm guessing is this stuff it's talking about. Well, maybe it's because it's already calling from the main. So no, but that doesn't make sense. What does that mean? I think you can search for what is a positional argument. It's better.
Hi everyone, in this video I want to talk about what keyword and positional arguments are in Python. Firstly, if you missed the previous introductory video on Python functions, I recommend you check out that first, and there will be a link in the description below if you're interested. So, when we have more than one parameter in a Python function, that means that we need at least two arguments from our user to satisfy those multiple parameters. But how do we enter those multiple arguments within the called function parentheses? Well, there are two options for us. We can use keyword or positional arguments. Let's first create a simple function with multiple parameters. Let's just keep it simple and create a greeting function that accepts the user's name and says hello to them. So we define our function using the def term and then enter a first and last name parameters that we need. And there we go. The function is now ready to be used. Firstly, let's talk about positional arguments. A positional argument is how it sounds. The argument positioned first in our function call will be assigned to the parameter positioned first in our function. So, since our function has first name as our first parameter, we need to put our first name, let's say Bob, as our first argument when we call the function, and likewise for the second argument for our user's last name. So, in summary, positional arguments just use the order of the arguments when calling the Python function. The other option we have to enter our function arguments is by using keyword arguments. This method for assigning arguments to a parameter is similar to how we define variables normally in Python. The benefit to this method over positional arguments is that the order in which you state your keyword arguments does not matter. So, to prove this, let's call our function again and input the arguments like so, with our last name argument first and the first name argument last. And as you can see here when printing, we receive the same output twice. So, in summary, both positional and keyword arguments can be used when multiple arguments are necessary for a Python function. Thank you for checking out this.
Still don't understand this. I'm guessing it should be here. Problem. But I'm not really sure. Maybe I should. Yeah. Oh, maybe I should put two arguments. Yeah. That's the problem. But what is the second one? Name or budget? Okay, so that was there. So each time, I think I understand a little bit better now. Each time that it calls, it's gonna create a. It's gonna create an object that is based on the framework of class category. And don't understand the budget though. Why is calling budget dot category? And if it's that from free code camp, or it has to be, I think, some code that they already provided. Category object has no attribute deposit. Why is budget dot category? I'm guessing budget is probably the parent class and category is the children. Maybe I'm wrong. There is no files here that import budget. So budget is just the method create spread chart.
This video, and I hope it helped your understanding of how we can enter arguments for Python functions, which is a class variable and which is an instance variable, but my point is that you could call them in the exact same way. Thank you for checking.
In the last video, we talked about defining Python classes and also defining methods within those classes. And as we know now, Python classes are the way that Python implements data types. And methods are the equivalent of functions in a Python class, but those functions are actually like inside the class itself, inside the data type. This lecture, what we're going to do is actually put the data in the data type. And the way that we do that is through what we call class instance variables. So let's get to it. All right, so last time we were working with this class called student, and we did a few very simplistic things with this class. Now suppose that we're building a system that is somehow being used to manage student accounts. Maybe it's a course registration system, or heaven forbid, something to do with tuition processing. In systems like that, a lot of data processing, data manipulation systems, but not just those systems. Also fun things like games and film editing, apps. You want to have the data. You start working with concepts, with types, right? You start working with the concept of a student, the concept of a game, the concept of a song.
Initially, first, I think I have to make a def for each thing that it is needed. I think that has to be the way that it's done. Def deposit, def withdraw. Because if each instance of a category is gonna have all these functions, then they are probably inside of the class. An amount and description. So I think I should write it down like this. So it's similar. There are not enough funds, nothing should be added to the ledger. This method should return true. So I'm assuming it's amount and description as well. It returns the current balance of the budget. So I'm not sure if I need this parentheses. I guess I need them because it's kind of like a function. The def statement. Transfer method that accepts an amount and another budget category as arguments. And another budget category. So I'm not sure what they mean by that. Maybe it's something like this. Because it has to be different. Oh, I'm doing on the get balance. Def transfer. Why is only this one giving me an error? Maybe it's because it's the same as this one. I'm not sure if I should use self as well for these arguments. This is another thing that I'm gonna write to look at. And to use self grading classes. It accepts an amount and another budget category as arguments. So maybe it's not description. The method should add a withdrawal of the amount in the description transfer to a destination budget category. So I think what they want me to do is to put another category there, but I'm not sure how to do this. So for example, if I have one category there's foods and another there's clothes, and I call this method, it should send from food to clothes. Clothes. The method should then add a deposit to other budget categories with the amount in the description. Transfer from source budget category. If there are not enough funds, nothing should be added to their ledgers. This method should return true if the transfer took place and false otherwise. Check funds that accepts an amount as argument. Trans false if the amount is greater than. Yeah, I think that's kind of the logic. So inside of each stuff, I'm gonna do what is required, and every time that it calls food dot one of these methods, since it is a class, it's gonna do whatever the function is doing. I think that's the logic. Maybe I should search for. Just need to understand better how arguments inside of the class, arguments of the functions inside of the class work.
Hey guys, in this video, I'm going to give you a quick introduction on how to use classes and objects in Python. I'm going to assume that you're already familiar with these concepts. So if you're new to the concepts of classes and objects, I'd recommend my introduction to classes and objects video first. Okay, so here's the class we want to create. It's going to be called robot, and it'll have 3 attributes or 3 instance variables: name, color, and weight. Those are the name of the robot, the color of the robot, and weight of the robot. And then it's going to have one function, introduce self, where when you run this function, it'll just print out my name is the name, whatever the name is. And from this class, we want to create these objects. The first object will look like this. It's going to have the name Tom, the color is going to be red in a string, and the weight will be 30 to show that it's 30 pounds. It's going to be an integer. And
It's real quick. So should I put ledger? Probably not.
and we're going to put this object in a variable called R1. And the second object we're going to create will look like this. This robot will have the name Jerry, the color will be blue, and weight will be 40. And then we're going to put this object in a variable called R2. So let's now see how we can create this class called robot and these 2 objects out of that class in Python. The first thing we need to do here is, of course, we need to create a class. For that, you can just write class robot colon, and notice here that R here is capitalized, and then 4 spaces after that, and we're going to implement the function we saw earlier, introduce self. For that, you can just write def introduce underscore self, parentheses, colon, and 4 more spaces after that, and then print double quotes, my name is, plus self.name. And this keyword here, self, is sort of like this in Java, and it'll refer to whatever object we're running this function on. So for example, if we run this function, introduce self, on an object whose name is Tom, this is going to print out my name is Tom, because self will refer to that object. Now this function, if you see it, it looks like a regular Python function. We're defining a function called introduce self, and then below that we have some implementation. But actually, when this function is within a class, when this function is a method of a class, you need to add an additional argument, and that's going to be called self. So this self is exactly the same as this self right here. So in Python, basically you need to add this additional argument called self to every method you want to add to this class. And once you run this block of code, this class is going to be created. And you might say, what about the attributes, like the name, weight, and color? We're going to worry about that later, so let's run this block of code for now. Now that we have defined this class, we'll be able to create an object out of this class. To do that, you can just write r1 equals robot, parentheses. Again, note that the word robot is capitalized here. And this simply says create a new object with the class robot. And here you're using the default Python constructor for this class robot. And to set the attributes, you can just write r1.name equals Tom, r1.color equals red, and r1.weight equals 3. And when you run this cell, a new object has been created. It's assigned to r1, and then its attributes have been set. And then if you want to run this function introduce self on this object, you can just write r1.introduce self, parentheses, and you don't need to pass in any arguments here. And when you run this cell, what's going to happen is it's going to go into this part of the code, and then self will refer to r1. And so this part of the code will look like print my name is r1.name, and r1.name is of course Tom here, so it should print my name is Tom. Let's see if it works. And it did. We see my name is Tom right here. And just like that, you can create another object too. Let's go back into this cell, and let's write r2 equals robot. This will create a new robot object, and then let's set its attributes too. So r2.name equals Jerry, r2.color equals blue, and r2.weight equals 30. Let's actually set the weight of r2 to 40, like we saw earlier. And once you run this cell, you'll have an object in r1 and another object in r2 with different sets of attributes, of course. And then at this point, you should be able to run r1.introduce self and r2.introduce self. So the first line should print my name is Tom, just like we saw earlier. And then the second line should print my name is Jerry instead. So let's see if we can get that. And that's exactly what we see. Okay, going back a little bit, when you see this block of code that we use to create these two objects, you might say, well, that's not great. Because here we're writing r1.name equals Tom, but if we misspell the word name, for example, if we wrote r1.namee equals Tom, it's going to stop working. Because if you look at this function in particular in this class, we're writing here print my name is self.name, and this piece of code basically depends on us writing the attribute's name correctly for it to work. What I mean by that is, for example, if you misspell the word name by writing r1.namee equals Tom, the attribute called name does not exist in this object anymore. So we can actually see what's going to happen if we try that. So let's run this cell again, and this is not going to give us any error because when you write r1.namee equals Tom, the attribute called namee is just defined, and then the value Tom is set for that. But when you run this block of code, r1.introduce self, let's comment out the second line and let's focus on the first line. When you run this part, it'll say attribute error, and it says robot object has no attribute name. And that's because it has the attribute namee, but it doesn't have the attribute name. So this is probably not the best way to deal with different attributes we have. Let's see how we might be able to fix that. And the way you can fix it is basically by using a constructor. And in Python, you can create a custom constructor with this keyword, underscore underscore init and underscore underscore. So there's the word init, and it's surrounded by two pairs of underscores. And then parentheses, and let's have this function take 3 arguments, given name, given color, and given weight. So these are the name, color, and weight we want to set for this particular object that we are trying to create. And then we can write here self.name equals given name, self.color equals given color, and self.weight equals given weight. And this block of code, of course, says set this object that we're just creating, set that object's name to given name, and set that object's color to given color, and set that object's weight to given weight. And earlier I said you need to add this self keyword, this additional argument, to every function we define in this class, and the constructor is no exception. So you actually need to write self as the first argument, and then the arguments that you want to add in. And actually, just like many other languages, a common practice here is to name these arguments exactly the same as the attributes that we want to set. You don't have to do it, but that's just a style thing, so let's just do that. Let's change given name to name, and then given color to color, and given weight.
I think what I'm gonna try to do is try to write each thing that it wants me to do on each of the functions, and if I get stuck, I will keep searching. Mount description. If no description is given, you should default to an empty string. The issue is that I'm not sure if I should use self for this. Probably not. The method should append an object to the ledger list in the formula. So I think it's as simple as writing ledger.append. then description. The issue is that if I do it like this, maybe it should be an empty string here. Because if I do it like this, it's gonna make the description equal to an empty string every time. But I think that's right actually, because if they don't put a description, no, but maybe if they put a description, it's gonna overwrite the description they are putting. So how to make an object?
To wait. And once you run this block of code, this class is going to be refreshed with a new constructor. Once we have a custom constructor in our class, the default constructor that we used will stop working. So let's just comment out this block of code, and then let's rewrite it using our new constructor. For that, you can just write R1 equals robots, parentheses, Tom, comma, red, comma 30. Let's capitalize Tom here. And then R2 equals robots, Jerry, comma blue, comma 40.
Hello guys, in the last video I have shown you how to use and how to define a function in Python. In this video also I'm going to continue with functions, and I'm going to show you how to use some other features in functions like default parameter and multiple parameters in function. So let's get started. In the last video I've shown you how you can declare a function. So you can declare a function in Python like this. Def, for example, I want to make a function to print out the score of a student. So I can say student score, for example. This is the name of my function, and in this brackets I can pass parameters, right? So for example, name and score. Okay, and then this colon, and inside this function we can write the definition or the code to our function. For example, I want to print something, print the student name and score. I can just write the or something like name scored this much amount of marks. So I can just write name and then comma and then scored and then comma. This should be scored, right? Not scare, comma marks, right? And this is simple. You have already understood, I think, the concept of defining the function and how to print these values, right? And if I call this function, it will just give me the answer. For example, I pass name as mark and score as 70%, and it says mark scored this much amount of marks, right? But sometimes you want that there are some default value which are already initializing these parameters. For example, in the case of databases, it's a bad idea to save blank values or null values in the database. So, and you cannot depend upon the user that he can define, or you cannot, be sure that user will define a parameter for every function. So what you can do in Python is you can define default parameter. So once again, I'm going to take this function, but I will initialize this function with some value so that it will not be null at any point. For example, Tom as name and score is equal to 0, for example, right? Now I can just print
So
the score and name,
that's what I mean.
and the default value will remain just the same, right? And my function is defined. And now when I use this function, and even if I don't pass any parameter, generally you have to pass a parameter when you define a function, and when you define a function with parameters. But when you initialize a function with the default value, you even skip passing the values to your parameter. And once I call this function, it says Tom scored 0 marks, because Tom is a default value and score of Tom is 0. Okay, so Tom is a default name and 0 is the default mark. And so you can ask, what is the purpose of this? The purpose of this is if the user will not pass any value as an argument, then default value will be taken. Otherwise, if the user enters some valid name, for example, mark and 85 marks, and once again, you can see it's printing mark scored 85 marks. Okay, so it has overwritten this Tom as mark, the name it has overwritten as mark, and the score is overwritten by 85, right? Now you can choose to pass the first parameter and skip the second parameter. For example, you can just pass mark here, and it says mark scored 0 marks, because this it has taken as the first parameter and it has overwritten the name, but we haven't passed the score, so it will take the score as default, which is 0. So it will print like this. Now for
So
example,
I think I get it. So I should put this inside of there. So it appends an amount, a dictionary with amount and description to the ledger. withdrawal method that is similar to the deposit method, but the amount passed in should be stored in the ledger as a negative number. Let's see if they. I'm just gonna. Let me think. I'm not sure if I'm supposed to make it negative. I think I'm gonna do that for now. So I'm assuming they're only gonna pass positive values. If there are not enough funds, nothing should be added to the ledger. So let me think. So what I need to search for is how to get the sum value of the key on a list of dictionaries. And that's gonna be the condition for the thing. Oh no. Oh no. So the first thing I wanna do is if and value gonna make a variable called value that is gonna be equal to the sum of the amounts inside the ledger. Value is bigger than 0, then I do the same thing here. And I shouldn't be worried about subtracting or editing anything when I'm appending, because the value is already gonna be negative. Nothing should be added to the ledger. So yeah, I guess this is the only condition. Oh, then here I return true. And then else return false. I think that's the way to do it. There are not enough funds, nothing should be added to the ledger. Return true if the withdrawal took place and false otherwise.
Hey there, how's it going, everybody? In this video, we'll be learning about dictionaries and how we can work with them in Python. So dictionaries allow us to work with key value pairs. And if you're coming from another programming language, then you may have heard these called hash maps or associative arrays. So when I say that we'll be working with key value pairs, these are two linked values where the key is a unique identifier where we can
Well, I can do a loop through the list and get the values. Or do I need the enumerate function? For money, ledger. I think these loops through the ledger and money is gonna be equal to each dictionary. Value is equal to plus equal to. Now here's the thing. I'm not sure I should do ledger dot amount. No, the money dot amount. So I'm assuming this loops through the ledger, and each time it adds the value of the amount to the variable value. But I also have to think about, let me think. Let's say they have 20 bucks in the ledger as the value, but they want to withdraw 50. That's not going to be possible. So if value is greater than amount, okay, instead of 0. Because I only want to withdraw when they have more money on the ledger than the amount they want to withdraw. I think this does it. But I'm gonna watch the videos just to make sure.
And find our data, and the value is that data. So we can actually think of that almost like a real physical dictionary where we look up word definitions. So in that example, each word that we look up would be the key, and the definition of that word would be the value. So let's go ahead and take a look at some examples. So let's say that we wanted to represent a student using a dictionary. So to do this, we could just create a student variable and set this equal to these curly braces, and that's how we start our dictionary. Now within our curly braces here, we will first put in our key. So let's say that we want a key of name. Now we're going to put in a colon to separate our key from our value. And for the name here, we'll just start off with John. And now let's add some more keys and values, and to separate these keys and values, we're going to put in a comma. So next, let's put in a key of age and a value of 25. And lastly, we'll put in a key of courses. And for this value, we'll pass in a list of courses here. So we'll say math and comp sci. So now let's print out our student and see how that looks. So if we save that and run it, then we can see that it prints out all of our keys and values. Now let's just get a value of one key. So to do this, we can add square brackets after our dictionary and then specify the key that we want to access. So I can put in square brackets here, and let's say that we want to access the name of that student dictionary. So I'll just pass in the name key and run that, and we can see that that gave us that value of that name key. Now if I wanted the courses instead, then I could just pass in that courses for the key. If I run that, then you can see that we got this list of math and comp sci. So we can see that these values in our dictionary can be just about anything. Our name is a string, our age is an integer, and the courses are a list. Now all of our keys are currently strings, but they can actually be any immutable data type. So usually these will either be strings or integers, but there are a few more data types that they can be as well. So for example, instead of name as our key here, if for some reason we wanted this to be an integer, so I'll just pass in 1. So 1 is a valid key. And now if I access that key of 1 and run that,
And also use Python tutor to see what this does. I also need to define the ledger now. Get the whole thing. Maybe I need to get everything. Actually, it's better. We're gonna try to do it just with the category to see if the budget is something free code camp added, which I think it is. We should pass food. Then food dot withdraw 20. And I'm not gonna give any description. Yeah, see if this runs. So I think it did. Great. Yeah, I created a category instance with food and ledger. Then it calls the method. Unsupported operands. Type as for into category. Unsupported operand types for. I'm not sure what this means, but I'm gonna try to turn this into an integer. It's gonna give me the same mistake probably. So it's saying that amount is category. Yeah, the issue is that I don't understand this really well. Let me do print amount instead. Just see what happens. Main category object. I think I'm gonna have to research this. Should look up on YouTube or Google or DuckDuckGo. Let me see if I put this not amount. Self. Not amount. Yeah, it doesn't accept. Let me try to put a description here. Which takes two positional arguments, but three are given. Oh, it has to accept floating values as well. I have to understand what is this positional argument. Because in my mind, I think that it is the arguments that I pass here from the videos I watched. Maybe it's because I'm making it equal to. No, the withdrawal is not equal to empty string. Why is it saying that I putting three there? Takes two positional arguments, but three are given. So I'm gonna watch videos about this, see if I understand.
And you can see that that gave us John. But I'm going to set that back to be a string for now and keep that as name. So what happens if we try to access a key that doesn't exist? So for example, I'll try to access the key of phone for a phone number. So if we run this, then we can see that we get a key error because that phone key doesn't exist. Now, throwing an error when a key doesn't exist might not always be what we want. So sometimes we might just want to return none or a default value. So to do this, we can use the dictionary's get method. So instead of accessing this key this way, if we were instead to say .get and use the get method. So let's just go ahead and get the name since we know that that key already exists. So if I run that, then we can see that that works just like before and gave us the value of John. But if I try to access a key that doesn't exist, so we'll try to access that phone key again. If I save that and run it, then by default, this get method returns none instead of an error. And we can also specify a default value for keys that don't exist. So to do this, we can just pass the default value that we want as a second argument to this get method. So I'll just put in a comma here and we'll put in a string that just says not found. So if I save that and run it, now we can see that for keys that don't exist, it returns not found. Okay, so let's look at how we can add a new entry to our dictionary. So let's say that we wanted to add that phone number to our student dictionary, and we'll set this just above our print statement here. So to do this, it's just as easy as saying student, and then we will set the key that we want to set, and set this equal to, and we'll just set this equal to a string of 5555555. And if I save that and run it, then we can see that it found that value of the phone key when we ran our print statement. Now, if a key already exists, if we set its value like this, then it will update the value of that key. So for example, if right below this, I was to say student and name is equal to, and we'll just pass in Jane. If I save that and then print out, I'll comment out that for now. If I print out our entire student variable, then we can see down here that the value for name was updated when we assigned it to Jane. Now we can also update values using the update method. Now this is especially useful when we want to update multiple values at a time. So for example, let's say that we wanted to add this phone number, update this name, and also update the age as well. So to do this all in one shot, we could say student.update, and this takes in a dictionary as an argument. And the dictionary is just everything that we either want to add or update. So we can say that we want to update that name to Jane, and we will update the age to, let's say, 26, and we also want to add this phone key, and that phone key will just set as what we had before, 5555555. Now if I save that and run it, then we can see that just by running this one statement, we updated the name to Jane, the age is now 26, and it has this new key of phone number. Okay, so now let's say that we wanted to delete a specific key and its value. Now, one way that we can do this is by using the del keyword, which stands for delete. So let me just remove these updates here, and then we can say, so let's say that we wanted to delete the student's age. So it's as easy as just saying del student age. And now if we run this, then we can see that now the only keys that exist are name and courses. So that age key was deleted. Now, another way that we can remove a key and value is with the pop method. So if you remember from our video on list, the pop method will remove but also return that value. So that allows us to grab the removed value with a variable. So we could say age is equal to and do a student.pop, and what we want to pop is that age. So if I save that, then we'll also print the age here below student. If I run that, then we can see that the age and value were removed from our dictionary, but we also created that age variable that contained the value that we popped off. So that popped off 25. Okay, now let's look at how we can loop through all the keys and values of our dictionary. So first, if we want to see how many keys we have in our dictionary, then we can just print out its length with the len function. So if I was to say print len of student and run that, then we can see that it returns 3 because we have 3 keys in our student dictionary. Now, if we wanted to see all of these keys, then we could just print out student.keys. If I run that, then we can see that that gave us all of the keys of our dictionary. If we wanted all of our values, then we could print out student.values. If I run that, you can see that that gives us only the values. Now, if we wanted to see the keys and values, then we could use this items method. If I run this, then we can see that now we have these pairs of key and value pairs. So we have name John, age 25, courses with the list. And we'll be coming back to these pairs in just one second. So if we wanted to loop through all of the keys and values in our dictionary, we might be tempted to loop through the same way we loop through our list. But if we just loop through our list without using any method, then it'll just loop through the keys. So for example, if you were to say for key in student and then print out that key, if we run this, then we can see that it just looped through and printed out all of those keys. Now, in order to loop through the keys and values, we'll need to use that items method that we just saw a second ago. And so we'll just plug that in there. We'll say student.item. And now these come in a pair of 2 values. So instead of just key, we're also going to have to access the value. So we can say for key value in student.items. And now we'll print out the key and that value. So if I run that, so we can see that each loop through, this key variable was equal to each key, and this value variable was equal to each value. Okay, so I think that's going to do it for this video. I hope that now everyone feels comfortable working with dictionaries and the functionality that's available to us. And in the next video, we'll be going over conditionals and how to write if, else, and else.
Oh yeah, forgot about that. Maybe this is a better way to do it. But I'm not looping through the dictionary, I'm looping through the list of dictionaries. So yeah, I don't know. I think first I'm gonna try to see on Python tutor once I figure out the arguments.
Welcome back, aliens. My name is 720, and let's continue the series on Python. Now, to this point, we have talked about functions, right? And now we know how to pass parameters as well. But when we talk about parameters, or you can call them as arguments, we have different types of arguments we can work with. Of course, arguments are arguments at the end, but then we can use in different way. So what I'm talking about here is, let's say I want to add 2 numbers. A very simple example, I would just want to add 2 numbers here. So what I will do is I will say def, I will get the method name as sum, or the function name as sum, and here I will mention 2 variables. Of course, right? When you want to add 2 numbers, we need to ask for 2 values, right? And we can give them name as a and b. So in a will be having the first number, in b will be having second number, right? And in order to find that, you have to put a colon at the end, and you will say c equal to a plus b. Now you have a choice here. You want to add, you want to print the value here itself, or you want to return. But that's not the main concern for this video. So time being, I will simply print it. What is important here is when you call this function which is add, you have to pass two values. You cannot simply say add, right? Of course, you have to pass values. So when you are accepting an argument here, you need to pass the argument as well, otherwise it will give you error, right? You can see, so when you press the control button and if you hold there, it says we have to pass two parameters, right? Now in that case, if I pass 5 and 6, so we are passing two values, right? Now these are called arguments. So the things which are accepting here, they are arguments, and this is an argument. Now this A here, so this A, B here, they are called as a formal argument. So we have two names here, we have formal arguments and we have actual arguments. So when you define it, it is formal, and when you pass the value, when you are calling a thing, which is called as actual argument, because you're actually passing something, right? So this actual itself, the actual argument has 4 types. It is position, keyword, default, and variable length arguments. So let's start with the first one. Now it's not that difficult, it's just with different names. Okay, so when you pass a value, example, if I want to pass 5 for this A, of course it is position, right? In fact, just for this example, we will take a different name. Okay, we will take a different method name. I will say the function name is person, and instead of, so when we talk about a person, that two things are important here. The first one is name, and second one is age. So we want these two parameters, and of course you have to pass them as well. So if I change this, let me change all the values here. So I define the function which is person. It takes two arguments. One is name and age, and so I'm calling person by passing name and age. So name is Naveen and age 28. So from this code you can see we got the value. It is working perfectly, right? Now how do we know that this Naveen is going in name and 28 is going in age? So that's where positions comes into picture. If you have 10 variables and you want to make sure that the values are assigned to the particular variable, we have to take care of the position. You cannot simply exchange the position. Okay, so positions are very important here. So when you are only depending on the positions, then of course we have to maintain the sequence. But what if I don't know the sequence? So let's say I have defined this function somewhere else. Okay, I don't have the access to this function. What I know is there's a person function which takes two parameters, name and age, but I'm not sure about the sequence. In that case, example, if I forgot the sequence here, and instead of passing Naveen first, I'm passing 28, and then I'm passing Naveen. This is where the problem starts, because we are passing a number first, and then we are passing a string. Of course, in this case, it will work. It will not give you any error. Of course, you will get the output in a different format, the way you're passing. But let's say if you're performing some operations on age, I want to print the age -5. That's what we all do, right? So whatever age is, we always say -5 with that. And if I run this code, you can see this is where the problem starts, because you cannot simply subtract.
Maybe the problem is the budget thing. I'm gonna try to do that. See if anything happens. The way that it's calling here. Budget dot category. No, it doesn't work. I think the issue has something to do with this init. When it creates the object. Extrude position or let me try to take this self off. Yeah, now it's not gonna work because it does not have a ledger. And it still gave me the same mistake. Yeah, category instance, category class. So this is the overall class, and this is the instance of the overall class. There's a name and a food. I think what's going on is that it's considering food as an argument somehow. So maybe I should put self.amount. And self.description. Take this off, see what happens. Yeah, maybe I have to do self.amount equals amount, self.description equals description. Now let's try if this one. And I think that's the only variables that I'm gonna give for now. Amount's not defined yet, so I have to put it here as well. But then I'm not sure if it's gonna ask me to give this each time I create an instance of a class. Yeah, so that's not the problem. Make it, maybe if I make it the default to empty string is gonna work. I'm gonna try to call the positive stuff. Yeah, same mistake. Takes one, takes from 1 to 2 positional arguments. 3 were given. So say I'm giving the same amount of arguments, and then 1 to 2 because he has a default. So the description is 20. And ledger is not defined. Maybe I have to tell it what it should be. Like amount equals number, something like that. When objects are created, they are passed in the name of the category. The class should have an instance variable called ledger that is a list. Maybe I shouldn't put self dot ledger. But I think I tried this already. Doesn't work. I'm gonna watch this video already.
song. And
That I
so
have opened
in our
already.
data in our example where we were working with students, and let's say we want to have them registering for classes, how are we going to distinguish the students from one another? We're just talking abstractly here. How do you distinguish a student from one another? Well, students have different data associated with them, different names, different ID numbers, different birth dates, different phone numbers, etc. And so it's really helpful in software development in general and to group together related pieces of data. And that's kind of, that's the premise of a data type. Strings in Python are collections of individual characters. Lists are collections of elements. And even integers, right? Integers are collections of little tiny bits, ones and zeros, that are used to represent a whole number. So, but we can make data types hold whatever data, low-level fundamental data, we want. So suppose that we have 17,000 students in our system. That's about what we have here at UNCW right now. Before, all our very simple class did was it printed out the person's name, right? And so, well, okay, if we want to have 17,000 students and we have different students with different names for the most part, well, using our first approach where we were printing out my name is blah, we had student and another student, right? Two different classes to print out two different names. Well, that's a little silly, right? If we wanted to do this with 17,000 different students, we'd have to have 17,000 different people, different classes. Well, that's no good. And also, well, then we evolved a little bit and we created a method. We made it so that our sayName method took a parameter. So when you used the class, when you called sayName, you could say, hey, call it with whatever value you wanted. Well, that's a little bit of an improvement, but still, if you wanted to have a student class and you want to say the name of 17,000 different students, you still need to know their names, right? Because you got to give the name to the student class. So that's not great. And it just makes more sense, right? What we want to have is the data associated with a person, with the big concept of a student, the real world concept of a student. We want that affiliated with the class. The way that we do that is through class instance variables. Okay, so here's our student class, and we're going to augment it a little bit. So if you're following along in the code, I would pause the video for a second, make it so that your code looks like this. Okay. All right, and now let's explain what we have done here. The first thing you'll notice is we've added this new method here. Okay, so this thing is a method. It looks like a function, but it has a very specific name, and this name is predetermined by Python. It is underscore underscore init underscore underscore. Okay, so these are two underscores crammed together, lowercase init. This is a baked-in thing in Python. You just have to memorize it. Okay, this method is a very special method that is called the constructor. There are constructor methods in other programming languages as well. The job of the constructor is when you want to make a new student class, or a new instance, this is the method that gets called implicitly by Python. Okay, so if you do not define the constructor method, and we didn't do that before, right? We didn't have this method before, and you call student, Python just gives you kind of like a blank student. Well, now what we want to do is we want to initialize some data in that student. And in order to do that, we need to define the constructor and give it the data we want to have inside the student. All right. So this is like formulaic. You just got to know this. Def init, and then this is a method. Init is a method, so its first parameter must be self. Now I'm going to give it a second parameter, and that parameter is going to be n, and it's the name. Okay. So what happens inside the constructor? I have self.name gets n. All right. This self.name, right? What is self? Self refers to the current instance of the class. It's saying put an instance variable, create a new variable called name, but it's on the whole class, okay? So that everything inside this class, including other methods, can refer to it, okay? So this self.name instance variable, you have to have the self dot here, but then you can call this part whatever you want. It could be name, it could be first name, it could be last name, it could be X, whatever. First part is self dot, and then the instance variable name. This is just a variable name, follows the same rules as other variable names, okay? So now self.name, right? That self.name value, the attribute value, is going to live inside my student instance for as long as the student instance exists in memory. Okay, so at any time, I can go to my student instance and access the name value, or the name variable, right? So down here in sayName, I've modified it a little bit. Instead of taking a parameter and instead of being hard-coded, it's going to print out whatever the value of self.name is. Okay, all the other methods inside this class can access instance variables by using self dot, the name of the variable. Okay, so go ahead and run this. I'll go over my code and I'll make it look like this real quick, right? So I'm going to define my constructor, and then I gave it. Now, if you're in PyCharm, you'll notice PyCharm will like autocomplete this for you, pretty nice. Def, start by doing my underscore underscore. Well, look at this. There's a whole bunch of them. We'll talk about them a little bit next video. But the second one on my list is init. So if I hit the, kind of scroll down, let me do it again. Kind of going down with my arrow keys, select it, hit enter, fills it in for me. Kind of nice. Autocompletes. Now, on the slides, I gave myself a second parameter. And what I did was I did self.name, okay, creating my instance variable, gets whatever value this thing has, right? This is just like a function definition. Whatever this parameter value is, I assign it here, okay? Now down here, I'm going to change my method. It doesn't take a parameter anymore, but what it's going to print out is self.name, okay? All right, so let's go back to the slides for a second, okay? So I've modified my student class. Now, I want to use it. I want to take advantage of this new structure. So note my line down here. Self.x gets, I want to use my new student class. Student, this calls the constructor, with an argument, the string Lucas, okay? So remember, the constructor is a method. So it can take arguments, it can take parameters, but you do not call underscore underscore init directly. This style right here, the name of the class followed by parentheses, automatically triggers the init method. Okay, so you do not call underscore underscore init underscore underscore with parentheses. You call this like that. Okay, and Python interprets it to say, oh, okay, he wants a new student, go find its init method and call it. Right, Python does that for you. So when I call the constructor with the argument Lucas, well, what happens? Python goes up here and it looks for the constructor, which it finds, and it substitutes in n here for this argument. Okay, so self, I called it with the string Lucas. It says, okay, n is equal to Lucas, so assign to my class instance variable self.name the value of n, which happens to be Lucas. Okay, so if we go back to our code and kind of do this, I'm going to punch in my argument to my constructor. Now when I run this, right, I'll initialize, it's kind of a two-step process. I initialize a new instance of the student class with this data, and then second step, I wind up calling sayName, and sayName is going to go in, find the value of self.name, which I already initialized, and it'll print it out. So let's run this. Oh, there it goes, right? My name is Lucas. All right, not too bad, right? But just kind of bear in mind, if your class is going to have data in it, you should initialize the variables in the constructor, and then you can refer to them in any of the other class methods. Okay. All right, let's go back to our slides. All right, so now the student has data. We can make multiple instances of students all with different data, right? So go ahead and punch this in. Student X. Okay, X is a student whose data is Alice. Y is a student.
Maybe if I understood what I was saying, I should put leisure here. Not sure if I should put self.leisure or just leisure. Maybe just self, maybe. Non-default argument, false default argument. Oh, the issue is if I put here as an argument, it's gonna ask for the argument of it every time that the withdraw or deposit is called. So or maybe not.
Whose data is Bob. Just like we have strings. You make a new string, X gets the string UNCW, Y gets the string UNCG, right? Two different instances of the string class, but with different data. However, they know the same operations as well, right? Students, whether you have data Alice or whether you're a student with the data Bob, both of you know how to say the name. Okay, so now this is a little bit more like how people do real software design when they're thinking about data. Now what we can do is if we're trying to build our, say, course registration system or our payroll system or our tuition system, what we would do is we would create different instances of students that all have different data. Okay, so this is sort of what it looks like visually. Here's our class diagram. X is getting a student with the data Alice, and Y is getting a student with the data Bob. X and Y are both instances of students. They look the same, right? They have an instance variable called name, self.name. They have two methods called init and sayName. But their data is different, right? That's what we have done here. We have created a data type called student that has some data value, but different operations, or excuse me, different data values. They're stored in the same place in the same name variable, but we're going to have different data values, but the same operations. Pretty cool. Okay, the instance variables have the same name but different values, and that's kind of an important point. In fact, it's so important. Why don't I try and make it explicit? The name here is Alice. The name here is Bob. Okay, right? But they have the same variable names and they have the same methods. Very important. Okay, so a couple big notes, big important things to remember about class instance variables. Instance variables are shared among all methods in the class. So any method can access an instance variable using that self dot, right? Self dot. Instance variables are always referenced with self dot when you're inside the class. And your instance variables should be initialized in the constructor. Technically, they don't have to be, but it's best practice that you do. Okay. All right. It's absolutely possible to have a constructor with multiple parameters, right? And previously, I just had the one, n. you can do multiple parameters just like you can with a function call. Same thing, right? What's it going to look like? It's going to look like this. Student X gets Alice, student Alice, comma, Jones. First, comma, last, right? This Alice matches to first, this Jones matches to last, right? Let's go over here and do this quickly, okay? Because I want to show you something else. All right, so I'm going to rename my instructor parameters to first and last. So I'll say self.firstName gets first, self.lastName gets last. By the way, it's always a good idea to kind of be explicit in your variable names. Your variable name should try to capture what the information is that they store. And in Python, the convention is not to do like first name all mashed together. That's not good. And in Python, you don't do this camel casing first big name. In Python, the convention is to do this. It's not syntactically wrong to do it this way, but the convention from the Python gods who created the languages do it this way. Underscores. Put underscores in there. Okay. All right. So let's modify our say_name method so that it says my name is self.firstName. Actually, you know what? Let's use an f string. We covered f strings early on. This is a great time to use it. My name is, put my little f here before the string quote, self.firstName, and then what? A space, and then self.lastName. Okay, so PyCharm's telling me I need to format my things better. Now I want to call my constructor, but I've got to give it a first name and a last name. If I forget to give it all the parameters it needs, it's going to yell at me, right? Missing one required positional argument, last. You forgot last, okay? Let's give my own name, right? And let's copy this. Let's make another student. Let's do Y gets the student Sammy Seahawk, and let's have Y say his name like this, okay? Run it. My name is Lucas Lehman. My name is Sammy Seahawk. All right, so cool. We got a student. It's got multiple class instance variables, first name and last name, and we can initialize them in our constructor and then use them later on in another method. That's totally fine. Let's say you want to change the data on your student instance. By default, any class that you define, any data type you define, is a mutable data class, right? That means that its data values can be changed. Python, though, has classes with immutable data types like ints and...
Maybe I should put self.ledger instead of just ledger. It's not gonna work. Maybe if I pass it in, it works. Yeah, it's not gonna work again. Well, maybe it did work. So let's see if I understand. I think it worked. Yeah, it worked. Nice. Oh, so maybe that's what it was missing there. See if it works. Nice. Nice. I think this works. So the problem is that I have to pass self each time. So the method has access to the instance variables. I understand. I'm still gonna watch the videos though, to see if that's really what's happening. Let me see what happens if I call the withdraw function. Now it gives me 20 demo. Ledger is not defined. It's the same problem. Forgot to put self here. So it doesn't loop. So maybe I have to initiate value to 0 each time. I think that's gonna be better. Well, the thing is that oh, that's the problem. Is that it's an empty list. That's why it's not looping through it. So I guess I could make. Let me change it here first. So if it doesn't, it's not empty, I run this one. And if it's empty, I run this one. And if it has something, I run this one. So I also think I can make value 0 here. Because what happens if value is 0? It means that either the list is empty or they didn't have anything to withdraw. So I think that's fine. Let's see if this works. It's probably gonna give me an error somehow. Yeah, nice, it works. So now let me call deposit first. Dictionary object has no attribute amount. That should be a string. I don't see any way to make this better. Unless I make dot, then the string method, and transform the string amount into. But I don't know. It's also not gonna work from the steps. So it worked apparently. Oh no, there's two else statements here. No, forgot about this. So this shouldn't be on a statement. The indentation kind of sucks. Go from Replit to the Python tutor. It's kind of an eye. So maybe I make a leaf here. So goes through this, then this. Yeah. Why is not going through the other ones? It added the first one, but don't understand why it's stopping there.
Strings and floats. Once you've created instances of an int, a string, a float, you actually can't change its data type or its data. It's stuck there. Our
Be right back. Yeah, I'm back.
Self-defined classes, you can change them. So how do you do that? How do you access, and also how do you access these variable values when you're outside of the class? Okay, it's different. So self.firstname has no meaning down here, right? Like say we just want to print out Sammy's first name, right? Well, self has no meaning out here, right? Self only exists in the context of a class. Right? So how do we, let's say we want to print just Sammy Seahawk's first name. How do we do it? Well, the variable y is holding the reference to our student instance with Sammy Seahawks data. So if I want to print Sammy Seahawks first name, I have to refer to his instance of the student. In that case, outside, right, when I'm outside student class definition, I need to use the variable that refers to Sammy. So in this case, y, right? Y.firstname will go to the instance of the student, and using my dot operator here, I can access the variable value inside the instance. Okay, so if I run this, the last thing I see printed should be Sammy, right? There it is. Okay, so I used, get rid of some of that junk on the screen, I used the dot operator before to access methods on a particular instance. I can also use, and more usefully, more importantly, I can also use the dot operator to access variables on a particular instance. Right? Now, if I print out x.firstname, what do you expect to see? What's the value of x? The value of x is the instance of a student with Lucas Lehman inside as data. Okay. Now, you can also take advantage of this dot operator to rewrite your data. Okay. So let's say Sammy is not satisfied being called Sammy, right? Let's say that she has updated her name and she's grown up and she's more mature. She wants to be called Samantha now. Okay. So y.firstname, the instance of a student holding Sammy Seahawk, dot first name. This is going to access the class or the instance variable, first name, and it's going to assign it a value, Samantha. So just like, if you had a regular old variable, you could do an assignment statement that looks like this. Well, if you want to access a class instance variable, put the instance of the class first, which is y, dot, and then the variable you want. Okay. So now when I print, or let's do this, let's print y.firstname. The change will be there. It stays there. It's recorded, right? So Sammy's name went from Sammy on line 15. We reassigned it on line 16, and now we have Samantha when we print it out, right? So that change was permanent. If we tell the student instance y to say its whole name by this, you will see that self.firstname has been changed. Okay, so this dot operator is very powerful, right? It lets you access both methods and instance variables on an object. Okay, so again, really important slide. Sit here and understand, digest what this dot operator does. If you're a visual person, the dot operator lets you take an instance x, y, and access the variables and the methods on that instance. That is the role of the dot operator. It's also the role of the dot operator in strings, in list, string dot split, string dot append. You are accessing a method on that particular instance of the class. Okay, so big concepts. Really understand it. We'll have a big homework where we get some practice with it. And I'll show you an in-class exercise here in a second. But let me kind of start to wrap up here. Why go through all this trouble of classes? Why go through all this trouble of data types? The answer is, to solve big problems, you need to be able to abstract away the details, right? So here's our Kia Sorento, kind of. My big head is over it. Whoops. Grab my head, move my head, right? When you're using a 2020 Kia Sorento LX front-wheel drive, you don't care about internal combustion. You just want to drive, right? When you are using a Spotify playlist, you don't care what the mechanics are of adding songs or removing songs or playing songs. You just want to manage the playlist. When you're using Instagram, you're scrolling through pictures. You deal in the concept of pictures. You don't deal in the concept of the individual pixel values or the compression used to store that data or anything else. It's a picture to you, okay? When you're picking classes in your course registration system, you don't think about the individual components of a course. You don't deal with instructor, time, location, course name, course number separately. You deal with them as a block all together, right? And that lets you think in terms of many different courses all in once, right? Instead of you having to manually connect the dots there, okay? So in life and in programming, it's incredibly useful to kind of abstract things together into types, into classes, so that then you can work on problems that are dealing with a type or a class, like in a course registration system. It's a little bit easier to think about it if you think of students and classes and instructors, rather than the individual data that make up the notion of a student or a class or an instructor, right? Classes and data types let us tame complexity. They hide the stuff, right? So we use classes, aka data types, to create concepts out of the constituent parts. We want the big picture item, not its dirty details. We need those dirty details for some things, but in general, I want to deal with the concept of a student. I don't want to deal with 850 number, first name, last name, date of birth, phone number. I don't want to deal with those strings. I want to deal separately, right? I want to deal with a student, and then that student kind of holds all that data inside, and I can access it. Okay, so we use classes to hide the details of how a thing works so that we can use that thing, that class, to solve bigger problems. Okay, so I'll sum up here with a little bit of vocab. You've heard me use these words a lot. They really need to sink in now, okay? Because we're gonna be using these terms forever and ever in this class and in other classes in your future, right?
Hello, everyone.
Classes are used to implement data types. Okay, classes define a new data type, allowing new instances of that type to be used in the code. Classes have instance variables for storing data, and they have methods for operating on the data. Okay. Variables and methods, this is a new term, okay, last one. Variables and methods together inside a class, those are called the attributes of a class. Okay. The instance variables and the methods inside a class are that class's attributes, and you use the dot operator to access attributes in a class. Okay, so I'm going to leave off here with an in-class exercise, where I want you to go over to that, the code we were working on with the student, add some more data in. Also, create another class. You can have multiple classes defined in a single Python script, okay, and I ask you to do some work
Hello all, my name is Krishna and welcome to my YouTube channel. So guys, today in this particular video, we are going to discuss about class methods and class variables. Now we are deep diving into classes things, guys, and we have learned a lot of things. I've also started OOPS concepts in my Python playlist itself. Now after this, we'll be going towards more advanced things. So please make sure that you understand what is the basic difference between class methods and class variables and what are things we'll try to see over here, right? It'll be pretty much amazing. Make sure that you watch this video till the end. You'll definitely learn a lot of things. Now, to begin with, what I've done is that, guys, I've just created a class car. I've created a variable. Remember, this is just like a variable. Okay, if you want to create a variable, you just use a variable name, you assign some values. I'll tell you what is the importance of this particular variable. Over here, I've taken the base price of this particular car, or whatever object of this car will be created. The basic base price will be this much. Okay. Now, after this, what I'm going to do is that I'm going to create an initialization constructor. Okay. After this, the initialization constructor will be my windows, doors, power. Okay. How many windows are there? How many doors are there? What is the power of this particular car? After this, I'm writing cell.windows equal to windows, cell.doors equal to doors, cell.power equal to power. Remember, these are my instance variables. Okay, that is getting created. Now, after this, I have also created a function which is present inside this particular class, which is called as what's the base price, and I've just printed that the base price is this particular value, that is self.basePrice. Remember, in order to access this class variable, there are two ways. One is by creating one instance. Suppose if I write car1 is my instance, and suppose if I write like I have 4, 5, 2000. Okay, this is the variable that I'm initializing. And if I write car1 dot base price, if I execute like this, then you'll be able to see that the base price will be able to get it. This is one way. The other way is basically to use the car class directly and then directly use the base price. If I also use like this, I will be also able to access this particular class variable. But usually what happens is that what is the best way, what we should do and all, I'll tell you in just a while. But just understand, if you really want to access this variable, you have two ways, either by creating an instance or directly calling the car class itself. Now remember, let me just consider one scenario. Okay, I'm just going to delete this because I just want to tell you one scenario. Suppose right now in 2021, the base price is this much. Now, probably in the next year when 2022 will come, what I want to do is that we need to add an inflation of the base price by 10%. Okay, I'll just give you this particular scenario. Okay, and remember, in 2022, whenever we try to create an instance of this, by default, the base price should be the recent price once we update it, by 10% itself, which is basically the inflation rate. I'm just taking this as an example. So to do that, we introduce something called as class methods. Okay, and in order to use or create a class methods, we basically use something called as decorator, which is called as @class method. Understand the scenario right now, guys. What I want to do is that every year I want to add 10% of inflation rate. This is my condition over here. And in order to add it on the class variables, we will just not assign it somewhere. We will just not change the values inside a function, but instead we'll try to use the class method itself over here. Now here I'm going to define the class method. And I'm going to say definition revise base price. Suppose this is my function that I'm creating, which is again a class method itself. And here I'm going to give two parameters. One, instead of giving self parameter, now I'll give the class parameter. This class, whenever we are defining the class method, guys, we have to provide this CLS parameter. Whenever we supply self, that basically says that it is with respect to the instance of this class. Whenever I provide CLS, this is basically with respect to the class type. Okay, this is basically this is directly referring to this particular class, like how we access car dot base price, right? This CLS will be referring to this particular class. Now apart from that, I will also tell my inflation rate. So I'll say my inflation rate. What is my inflation? And here, now what I'm saying that as every, like right now it is 2020. Suppose we go to 2021, I need to change my base price. Probably I'll be changing my base price with the help of class method, and this will be very, very handy when I'll show you the example of initializing things. Just give me a second before that. Now suppose I want to update this particular base price, so I'll write CLS dot base price is equal to. Please listen to it. It is very, very important. So I'll write CLS dot base price plus inflation. Okay, plus inflation. I'll not just write plus inflation. See, I'll say that CLS dot base price multiplied by inflation. Okay, suppose my inflation is 10%. I need to find out what is the 10% of this particular value, and that value I'll be getting it over here, and then I'll be adding that to my base price. So this is what my class method is doing. Okay, if I want to change this value such that in 2022, whenever I make an instance of this particular car class, the base price should be the updated price or the revised price, and for that I'm using this class method. See this, guys. Now let me just define car1 is equal to car1 is equal to some values over here like 4, 5, 2000. Suppose 2000 is my power. Now if I execute this over here, suppose my car1 dot base price is something like 1 lakh INR. Okay. Now remember, suddenly now we went into 20.
So one way that I just thought about it is, instead of looping through the self.ledger, I can create another empty list here, and then that doesn't work. Maybe instead of getting the value, I just append the amount to the new list to prevent it from returning something. Let me print soft.ledger. See, understand what it is. Yeah, so I got it right, but is the object? Self ledger is the list. The issue with doing the task like this is also that the ledger is gonna be infinitely big the more times is used there if it's never removed. But I think it's probably more complex to make something that remove the dictionaries. That's why they made it like this. That's why they made the challenge like this.
A number by a name because so Naveen is getting passed in age, right? That's what the problem is. I don't want to do that. I don't want to assign the value 28 to name and Naveen to age. In that case, if you don't know the sequence, you can simply say, hey, age equal to 28 and name equal to Naveen. So in this case, we are using keywords, right? So when you say keyword, it means you are mentioning the variable name itself. So variable is age, which is 28, and variable is name, which is Naveen. In this case, it will work. Okay, you can see we got Naveen and 28. So this is the keyword arguments. The next argument is default. Now what it means. Example, I want to pass a name and I don't want to pass an age because by default, like, let's say if you want to open an account in social networking website like Facebook, maybe there's a
Maybe it's the indentation that's wrong here. Well, but then, yeah. It's only gonna go through this statement if this one is correct. Yeah, maybe that's right. Invalid syntax. Also, I also realize now that the amount's gonna be negative. So I have to figure out a way to maybe just do the same calculation, but there's probably a method inside Python that makes numbers be always positive. Yeah, I think this maybe is just if instead of elif. Yeah, nice. Yeah, nice. So it works. Nice. Let me think about it. Yeah, I was thinking about the amount stuff. So let me fix this before I forget. The simple way is obviously multiplying by -1 again, but I want to see if there's a special method for this. Suggestions are funny. Method for making number positive. So abs. Well, but before it was appending as well. Oh yeah, because it's bigger, obviously. Now let me make a bigger value. Let's see what happens. So now it's not working. Yeah, it's probably the indentation again, but I can make itself ledger is equal to. That way I prevent anything from happening before. No, but then this else statement doesn't make any sense. I think, yeah, now it's right, probably. The same line, this one. It's just the indentation is kind of weird. So if value is bigger than the amount or different than 0, appends, and if it doesn't, it turns false. Nice. Okay, it works. So this has to be here. So I think that's it for the deposit and then withdraw. I think I'm gonna watch the video now and then go try to do the other classes, the other methods. This one.
2022. Obviously, 2022, I told you that because of the inflation, we definitely need to increase the base price. So what I'll do is that instead
See
of
how
just
many
creating something, I'm
hours.
just going to delete it. Instead of doing this, what I will do is that I will say car dot revised base price, and here I'm just going to say that this is my inflation rate, 0.10. Now once I execute this, so here I'm probably getting an error saying that name inflation is not defined. Why? Okay, so this will be my CLS. Inflation. Oh, sorry. The parameter is a little bit wrong over here, so I'll just make it as inflation. Let me execute this once again. And here, now let me just execute this. There was a small spelling mistake. So here you can now see if I write car dot base price it is showing 1,10,000. See, there is an increase in 0.10. Now, whenever I create an instance saying as car1 is equal to car with 4, 5, 2000, and if I try to execute it, now if I try to see car1 dot the base price, here you'll be able to see that it has got updated. It has got updated. See, I can also call this particular method by using my instance like car1. I can definitely call it. If you want to see this particular example, see this. I'll say that okay, car1 dot revise base price. Again, I want to increase it to 10%. Okay. Now see this. This is also a way to call it, but in the real world practice, this is not used, guys. Whenever we want to do an updation with respect to the class variables, we may use class method, and always it is done by using this particular technique where we are using the class name dot that particular function name. Yes, we can do this. This also. See, if I now go and see my car1 dot what is my base price, here you can see that it is got still updated. And whenever I create my next instances also, suppose if I create my next instance like class 3, suppose I have 3, 4, 2000, right? Even though I create over here, and if I try to see the base price will also get updated. It is also possible by the instance, but usually in the real world scenario, by considering the good practice, it is not done in that particular way. But I hope you have understood why do we use this particular class method and how it is basically used. Why we have used CLS over here specifically. When we are using this CLS and when we are updating this particular value, once it is updated, then any time I create any new instance, that new value of that particular base price will be updated. Now here in this particular case, even though I use this instance where I changed my base price by again 10%, my base price was this much. Then again I created a class 3 instance, and then that time you could see that my new base price was something like this, right? This you can also call it like this, or you can also call it like this. But in the good practice, where I've seen many good developers, where I've seen projects, they basically use this particular technique, right? So I hope you have got an idea of class method. What is this? This is basically a decorator. Try to see some of my examples in decorator which I've explained in my previous session, in my complete Python playlist. But now I hope you have got an idea what is class variables and what is class methods. Class methods definitely can be used to update the class variable only once, so that whenever you're creating the newer instances, automatically that value will get updated. Now I don't have to do anything. As the year changes, I'll just go.
Everyone, Dr. Lehman here, back with a really important concept that's going to carry you through the rest of the semester, and that is Python classes. So in this video, we're going to get started on implementing some Python classes. So last video, we talked about data types and their relation to Python and how Python uses them in memory. Well, in Python, there is a mechanism, as we mentioned last time, for implementing your own data types, and that mechanism is called a class. Right? Now, if you have a Java programming background, you're very familiar with classes, and maybe you got exposed to classes before. That's fine. We're going to go over them again, and we're going to make sure you really understand them, because throughout the rest of this semester, the rest of this course, you will be writing classes, and you will be using them to solve more complex problems. And if you remember last time, we asked the question, why do you have data types in programming? And the answer was, well, to abstract details away so you can focus on solving bigger problems. That's what we will use classes for in this course, which is kind of wrap up some details of things in little packages called classes and data types called classes, and then we'll use them to solve other bigger, more interesting problems. Okay, so in Python, classes define a new data type, just like you have string class, int class, etc., allowing new instances of that type to be used in code. Classes have instance variables for storing data, right? Remember, data types have two things. They have data and they have operations. Well, in Python classes, the data are kept in what we call instance variables. We're going to talk about instance variables in the next video. And then the second thing you get with a data type are the operations you can perform with that data type. And Python classes, these things are called, they're not called operations, and they're not called functions, they are called methods, okay? So let's get into it. What I would like you to do is fire up an interpreter, preferably PyCharm, because we're going to be doing a couple of lines of code at a time. You're going to want to rerun everything. So get your editor open, and then anytime you see code on the screen, I want you to follow along, okay? So in your code, so type this up. Here we are going to define a very, very simple class, and we're going to call it student. And this is going to create a new data type in Python for us to use. Now, this new data type that we're going to create, it's only going to be there like for as long as our current Python interpreter is running. It goes away, right? If you reboot your computer or Python crashes, forgets all about it, about this class you create. All right, so how to create a class in Python? Well, you need this keyword called class. Should be easy to remember. And then you give it a name. Okay, class names in Python are capitalized, right? They are camel case or title case, as some people call it. It's capitalized. And then inside our very basic, very simple class that we're going to call student, so we got class, and then the name of the class, colon. We come down and we do our 4 spaces in, or our tab character in. We are going to define a method. Now remember, methods in class terminology are the operations of the data type. There's going to be a lot of vocabulary in this lecture, so you need to really let it sink in. Maybe you need to watch it a few times, because there's a lot of super important terms we're going to keep introducing in this lecture and just use over and over and over again throughout the semester. Okay. Inside our class student, we are defining def a method. Okay. Method is the operation on our data type, but methods, you can just think of them as a function from Python that is declared inside a class. Okay. So it's a function. You all know how to define functions, right? And what functions can do. Python methods are just functions that are inside a class. Okay. Everything you can do with a Python function, you can do with a method. It's just that the method lives inside the class. So I want you to think of classes and think of instances of classes when you're using them. Think of them as a little box, right? And things live inside that box that you need to get access to and can use to solve problems, right? So to define a method, it looks very similar to defining a function. You start with the def keyword, and it's tabbed over here, so you know it belongs inside the student class. Then you give it a name, okay? Method names, function names in Python should be all lowercase. And then there's always one, at least one parameter, and that is called self. Okay, just like this. Self is a key word in Python. We're not going to go into what it means right now. We will get to that back at the end of this lecture. Okay, so, but remember, anytime you will ever define a method inside a function, self must be the first parameter, and it must always be there. Okay, so hop over to your code, make sure you've got this typed in. Your code should, well, actually, I'm going to come back here. Okay, this is just the class definition. If you go ahead and run your code, it won't do anything, right? It should run, but there won't be any output. Okay, and that's because what we're defining here is think of it as defining a blueprint. This is what a student class can do. But we have to actually create one of these things and use it, right? Just like Python has string classes that are defined, well, one string class that is defined, you still have to make an instance of a string class in order to use the string, right? So here's how we create an instance of our student class. We call student the name of the class, it's got to be this, right? Followed by open paren, close paren. So this looks a lot like a function call, or a method call. And in fact, that's what it is. It's calling a special method called a constructor. We will come back to constructors in a later video, okay? Next video. But anyway, just know, hey, I need a new student I want to play with. You call it like this, okay? This call returns an instance of the student class and assigns it to the variable x. This is just like you saying x gets 1, or x gets the string Alice, right? X gets student gives you a new instance of this. Okay, you can have multiple instances. X gets student, Y gets student, Z gets student. Make as many as you want, just like you can with strings or ints. Now, I want to call this thing. How do I call this method? You use this syntax. X dot, this is the dot operator, say name. Okay, so this calls the say name method on the instance of X. Right? So go over to your code. Your code should look like this. Zoom in a little. And if I go ahead and run this, it's a little gray up here because I don't have the appropriate white space, I think. Oh, no, it's a different warning. Ignore that. Here's the code we had from the slide. Go ahead and run it. Right. So you can see down here, the output did happen. So what happens here? What's going on? Line 6, we get a new instance of the student class. And think back, right? Think back to the last lecture. Classes are like the Kia Sorento 2020 for front-wheel drive L, or whatever it was. When you do this, you're saying, hey, give me one of those. You go to the heap and you get one. Okay. And now I'm saying x dot say name. Whoops. So this says, all right, take my instance, my particular car of student, and on that instance, invoke the say name method. So up here, say name, what does say name do? This is just now like a function call. You call this, and it says, oh, okay, the user, the programmer wants me to do say name. Where is say name? Let me go up here to the definition. It does any parameter argument substitution it needs to do. We'll come back to that later. And then it goes inside the function and runs the function body, okay, which in this case does the print statement. And then it comes back out to where it was called, right? So we leave line 3, we come back to line 7, right? And we're done. We continue on, right? We could do more here, so let me just print something, right? So we're going up here, invoking this method, looks a lot like a function. Finishing our execution, we come back down to line 7, then we go on to line 8. All right, that's all that's going on here. Not too bad, right? It's just kind of like a funky function, but with extra steps. All right, let me get out of this. Go back to my slides for a second. Okay, so you saw the dot operator that we used before. Well, you have seen the dot operator before in your life programming, right? Like if you were using a list, you could append to a list, right? And you called x, here's my list x, dot append something, okay? Or maybe you had string dot split, string dot strip. This dot operator, what it does, what it's really doing, is it is used to call a method that is defined within a class. Okay? So when you call x dot append, what Python does is it goes to its class definition for the list, goes down, finds the append method, and then invokes it, right? And the method is just a fancy function. Okay? So that's what the dot operator does. It calls things, calls methods, and later we'll use it to access instance variables on instances of classes. Okay? Let that sink in. Right? Understand what the dot operator is doing. It's going to the class instance and calling a particular method on it. Okay. Now you know how those methods are defined. They're defined this way. All right. Let that sink in a little bit. You can also have instance methods with arguments. We'll do that here in a little bit. Okay. All right. But let's go back and play with some more classes. Right. So what I want you to do is copy and paste that student class you just created and make a different class called another student. Okay. Just change the name to another student, but have their say name print out something different. Right. So, and then we're going to call this code. X gets student, x dot say name, y gets another student, y dot say name. Okay, so let's go do it together. Okay. All right, so here's my code. What I said to do is copy this stuff. Okay, copy and paste. And I said rename this to another student. And change this to print out a different name, Alice. Okay, so these look very similar, right? But they are different. I'm actually going to create 2 separate classes here. And we'll prove to ourselves that it is 2 separate classes. So I'm going to create an instance. I'm going to get an instance of this other class, another student, and I'm going to tell it to say its name. Okay. So what do you expect that the output's going to be? Well, it should print. First I get x, say my name is Lucas, then get a value, this different class, and call say name, and say my name is Alice, right? So this is where, like, the methods are really important. Okay, so Python is not going to get confused. We've got two methods here that have the name say name, but they're defined in different classes. So even though you're calling the same looking thing down here, Python knows the difference. It knows that when you call x.sayName, it should go to student, because that's what x is. It's a student, and call students sayName. Okay. Y is another student, it's a different class. So when you call y.sayName here, it's saying, oh, wait a minute, go to y, which is an instance of another student, and call its sayName. Okay, so let's go back to our slides and try and draw a picture about what's going on in here. Okay? So here's a visual representation of what we've got going on. It's a class. It's called a class diagram. Maybe you saw these in a previous class, but it's a way of thinking of classes and instances of classes visually. So X in our code is an instance of the class student, and the class student has defined on it a method called sayName. Y is an instance of the class another student, and it also has a method in it called sayName. All right. So let's run it again, but let's change it up just a tiny little bit. Okay. So we're going to take our code and we're going to reuse, or we're going to reassign the variable X. Okay. So let's go over here. X gets another student, and then x.sayName. Right? Student variables, these variables for your custom data type, they can be reused. Ignore that stuff down there at the bottom. My name is Alice, my name is Lucas, right? From our previous lectures, remember, variables just hold references to objects in memory, to instances of classes that live in memory. So here, X is a student, and we call sayName. Here, I reassign the value. I create another student instance, assign it to X, and then call X sayName. It all works out just fine. Okay, go play with this in the Python tutor. Plug this into the live visualization and step through it item by item so you can see what happens. Right? All right, let's go back to our slideshow again. Whew, instances, classes, objects. Oh my! You know, these are.
Stop here. I'm gonna try to get balance, and then I watch the rest of the video. Returns the current balance of the budget category based on the deposits and withdrawals that have occurred. So that's the same thing as the value, I think. Initially, 8 value is 0. And I just do this loop here. Oh. Should copy both of them. Uh, 0. I'm not sure if I should return a number or a string when the list is empty. And here I should return value at the end of the loop. I'm putting outside of the loop because otherwise I think it's gonna return on the first iteration. So I think that's it. A transfer method that accepts an amount and another budget category as arguments. So amount, budget. The method should add a withdraw with the amount in the description transfer to destination budget category. Should add a withdraw with the amount in description. So this should call withdraw function, I think. Now here's the thing, I don't know if this is gonna transfer to this. transfer to I should do the F here. Budgets. So if I understand, this is gonna be the other category. And then this calls the withdrawal function with the amount and the description. The method should then add a deposit should the other budget category, the amount in the description transfer from source budget category. So how I'm gonna do that? I should call the deposit. Oh, but the deposit is only gonna deposit for this class. Our budget dot deposit, because budget is supposed to be another category. Then I send amount description equal to, which is the same thing that I did here pretty much. Not sure if it's gonna work, but I deposit to the other budget category of the amount and the description transfer from source. So I have to think about, I think this is self.name. Yeah. There are not enough funds. Nothing should be added to either ledgers. So it's pretty much the same condition that I did here. Don't understand why this is wrong though. Oh, actually, I need to check for the amount, not the. There are not enough funds. Nothing should be added to either ledgers. So I should check the value first. Maybe it would be better to just make value a variable inside of here. I wonder if I can do this, because then I can just put value equals 0 and keep track for all the other ones. Yeah, let me see this. So apparently it works. Let me erase from here. See what happens. Yeah. So I have to declare it each time. I guess. Don't understand why this is highlighted, but it's just might be Replit stuff. So if the ledger is empty, returns false. Maybe it's an indentation thing. I think I'm gonna do the same thing that I did here. Actually. The method should then add a deposit to the other budget category of the amount. Now I think works. There are not enough funds, nothing should be added to either ledgers. This method should return true if the transfer took place and false otherwise. So I think this works. Check funds methods. Method that accepts an amount as an argument. It returns false if the amount is greater than the balance of the budget category. Let me read that again. Accepts an amount as an argument. It returns false if the amount is greater than the balance of the budget category, and returns true otherwise. This method should be used by both the withdraw method and transfer method. Oh, so that makes sense. So what I should do instead is copy this code into check funds, and then instead of doing this, I run check funds each time. They could put this one as the first one. It would make more sense, I think. So I guess it's just this first two parts here. Turns false if the amount is greater than the balance. I think I'm just gonna copy this stuff. Put here. I think that's pretty much it. Returns false, the amount is greater than the balance. Budget category. Returns true otherwise. Now I have to think about how to translate this into the other ones. Let me copy this stuff that I did to here so I don't lose it. So I guess this goes away. And this goes away too. So if check there are funds amount is equal to true, then I also do this. I think this works. So if it's equal to true, it means that it has balance. And if it doesn't, it's gonna return false. Or maybe value bigger than amount. Yeah, they're gonna put an amount and it's gonna see if the value is bigger. the amount is greater than the balance. I'm not sure about this value different than zero condition, but so I think this is correct. I'm gonna see on the Python tutor. Fuck. Line 13. Let me see if here. Oh, it's wrong here too. Let me copy again. Invalid syntax. I forgot the self, maybe. Invalid syntax. Maybe I should just call with the self and not the amount. So let me search this.
There's a criteria that you should be 18.
How can I type this? Which call methods from other method. Python.
Hey guys, welcome to the video. This video will be very useful, so please do see. I'm gonna show an example how to create a class, and I'm gonna create two classes and which has two methods. How to call another class method from one class. So when you are working within a class, you wanna call other class, which is gonna return some value. So let's do it. It's gonna be really useful for your understanding. So I'm gonna create a class here. So hopefully, if I can zoom in. All right. So if I have a class here, if I say object, right? Jesus Christ. All right, so we have an object. Sorry for that. Let me say underscore in it. Pass. Let's say I have a method A, and this will simply say class A method, class A method. So and the method name. This will really clear all your very important concepts. So and similarly, let me just say this class will return a string, right? And that will be true. Again, I have a class B object, right, which will inherit from object.
Maybe I have to do a self dot check once. Self amount. Let's try it just with the self. Yeah, it doesn't work. Oh, it's the dots, not the thing. Nice. Okay. check Netherlands funds is not defined. I forgot which line it is. $13. Let me try salvage. At least it's a different error. So maybe you just put amount here. The thing is, I want to pass the amount. Oh, and that's the issue. I forgot that so I have to pass absolute amounts. Because I'm multiplying by -1 there. Nice, I think this works. So here's dots. What else did I put this? Okay, but now it's saying that everything is wrong. Oh, I put in this. I was confused the show. I think I have to do the same thing. Yeah. Now I have to understand why this is giving me a mistake here. Maybe I have to pass south here. Nice. Okay. I think this solves everything. I wanna run it, but I'm afraid that's gonna give me a bunch of stuff wrong. Withdraw line 13. Oh, that doesn't make sense. Because check funds doesn't have a. Oh, it has to have self here, I think. Maybe that's the problem. Yeah, so it doesn't have self. So I should make withdraw equal to empty string as a default for failures. Okay. So at least I'm on the right track. So I think the errors are coming from this stuff I haven't done yet. Yeah. Good. Besides the category class, create a function outside of the class called create span chart. So it's this function here. That takes a list of categories as an argument. It's already there. It should return a string that is a bar chart. The chart should, I think I'm gonna search this.
And
Oh, I think I understand what they mean. They want me to create a string that is formatted like this. Oh, this is gonna be tough. The chart should show the percentage spent in each category passed into the function. The percentage spent should be calculated only with if draws, not with deposits. Each category passed into the function. So let me think how I can do this. I need to check funds. No, check funds is gonna return true or false. I need to run a loop for each category to know the value. The percentage spent should be calculated only with withdrawals and not with deposits. Oh, the percentage spent. So I'm guessing this is the hardest part of this challenge. Yeah, so I have to access the withdraw amount for all of them are gonna be negative. So I can take the negative amounts from the ledger. The bars in the bar chart should be made out of the O character. The height of each bar should be rounded to the nearest 10. The horizontal line below the bars should go to 2 spaces past the final bar. Each category name should be written vertically below the bar. There should be a title at the top that says percentage spent by category. Yeah, I have no idea how I'm gonna do this. This function will be tested with up to 4 categories. So the first thing I need is to take the value of each one. Now the thing is, should return a string that is a bar chart. So we need to think about how I'm gonna do this string. Each category name should be written vertically below the bar. Should be a title at the top that says percentage spent per category. So what's gonna be the name of this string? Per string. Then we'll have percentage spent by category. New line. I think the Zoe, I can do it with z dot fill. Zfill was a method I was looking at on the previous challenge. But I think it fills the thing with zeros and not O's. So the amount of O's must be determined by the percentage of each one. down by 10. I'm just gonna do the chart manually to see. For each one, I want to be a new line. I want to have a new line. It's gonna be this. Oh, actually. Then the number of dashes I'm also gonna have to change. So I'm gonna have to make a variable for this, probably. And then here I'm gonna have to make another variable. It's gonna be n times then categories. Well, categories is gonna be a list of categories. Takes a list of categories as an argument. So categories is a list. So actually this doesn't make sense. I'm gonna get the index. I can loop through the list and get the index. Or I can just do categories dot length categories. That also works and it's more simple. N equals length categories. But how I'm gonna access each one? That's the thing. I think I can create a variable maybe equal to the for loop. I loop with the index and then I also have to think about the formatting, not just getting the name. Let me see what time it is. I think I'm gonna go have lunch and then I'll come back and try to do this. I'm probably not gonna be able to do this by myself. I would have to look at the other people's solutions. But I think first I'll try to do it by myself. Then if I spend 1 or 2 hours and I can't make anything happen, then I'm gonna look at the other people's solutions and then try to do it again. So yeah, see you then.